Hello. This presentation will describe the Data Science Clinics project for the UChicago Library. My name is Shailesh Bolduc, and my team is Nick, Kaitlyn, and Sean. A little bit about the project. The library is facing growing pressure to manage its expanding physical collections efficiently as the library's book collection increases in size by about 1.4% each year. In context, that's over 80,000 new books annually. However, they're now running out of space to store things on campus. Due to this high growth of the library's collections, the library hopes to optimize storage without compromising accessibility of the library's physical collections. By accessibility, that just means how quick can a student get a book in their hands when they want it for research or something like that. So this project and the team for the Data Science Clinic is going to prioritize identifying which materials should be relocated off-site without sacrificing accessibility, while also considering external factors such as books being used more in election years or the acquisition of electronic copies. How are these going to affect usage? And that brings us to the problem statement. Given data on the library's collections, how can we better understand the items that the university has? What attributes of this data can help us determine which volumes should be relocated to offsite storage? The final deliverable in response to a question such as this would be a proposal of which volumes should be removed for offsite storage. The library also indicated that our process to deliver this proposal could be useful as a reusable tool. So maybe after 10 years, the library wants to perform something like this again. So they need to analyze what's trending in 2034, or they need to see what other attributes of the data have come up in the last 10 years. So they can just use our workflow from end to finish to create that new recommendation. So our final workflow would look something like this, starting from data processing, so cleaning the data and making sure that certain features are usable. And then going into genre labeling, which is just a way to ensure that we have a high-level classification for different books, because there are about 6 million copies in the library's physical collection, so analyzing them individually would be pretty tiresome and inefficient. Next, we would go into feature extraction, so actually just identifying which features are or are not useful in determining whether a book should remain on site or not. And then finally, weights and scoring, which is just that final calculation of, okay, this book is very important to keep on site, or this book is not so important and we could remove it off site.
The library's collections data, which is data about all the records and volumes that they've acquired, was given to us in a free-form format that is common for libraries to use. In order to reduce the storage size, we retained only relevant information for every record in a tabular format. This includes information like title, author, and date of publication. This resulted in 12 times storage savings, which makes the data much more manageable on our local computers. The usage data we were given included all check-ins and checkouts for the past 10 years. We were able to reduce the dataset to only actions pertaining to physical records and checkouts within the institution. We wanted to be able to group records based on their genre in order to make recommendations about specific records based on ones that were similar to them. Thus, we attempted to use clustering techniques to form these groups. We researched ways of transforming our data into numeric representations, clustering algorithms, and ways to assign labels to groups of records once they're made. However, we ran into issues with clustering, and only around 30% of our records ended up in groups. For our first analysis, we reverted to using a pre-existing feature in the data that gives us a sense of genre, but that might be outdated or biased. And we will be revisiting this clustering idea next quarter in our second pass of analysis.
The next step in our process was feature extraction. This is where we cleaned, combined, and or performed operations on existing columns in order to help us answer the question, what characteristics of a book can help determine if it should be kept on site or not? Some of the features we extracted in order to help us answer this question are number of duplicates, year published, number of checkouts of a book's genre, number of unique checkouts within a genre, rate of change of checkouts with a genre, among others. I'll give you a couple of examples of these just so that you're familiar with these terms. Number of duplicates is literally how many extra copies of a specific volume are there. If there are 8 copies of a book in the physical collections, maybe we can remove 7 of those to make space for 7 new books. Year published is another important feature because the library indicated from institutional knowledge that they would prefer to have newer books in their collections than older books. So a book published in 2020, for example, would be weighed as more important than a book published in 1840 for this feature in specific. The final step in our workflow was weighting and scoring. Each book is given a numerical score that determines how important it is to be kept on site. Books in the bottom 20% of scores are then recommended for removal. The number bottom 20% was chosen because this is the number that the library recommended to us, again from domain knowledge. They predict that by removing 20% of the books, the library won't have to remove books for another 10 years, while also not taking away too many books at once. It's a good balance. A weighted sum of the extracted features is what gives the final score of a book. And below in this pie chart, you can see that an almost exact weighted sum of the extracted features we used for the first attempt at our model. The most important feature was number of checkouts by genre. So essentially, if a genre was checked out more over the last 10 years, so more people are interested in that genre, then it was weighed as more important to be kept on site. The other features we used were whether it has an electronic copy, the published date of the book, the difference in the number of checkouts between 2014 and 2024, so a rate of change, just seeing if that's positive, negative, so losing value or just kind of staying the same, and then whether it has both electronic copies and duplicate physical copies. We further penalize that on top of the has an electronic copy feature, because if it has both a copy online for students to read and multiple copies in the physical collection, we can definitely remove a book like that to make space for new ones.
Here we see the distribution of our calculated scores for the approximately 6 million physical items in the library's collection. The cutoff line indicates a score cutoff for an item to be marked for removal, with items with scores lower than the cutoff score being marked for offsite storage. While the scores range from -2,000 to 1 million, all items except a few thousand have scores ranging from -10 to 10. The extremely high scores represent items that have been checked out many times, while extremely low scores represent items that have never been checked out or their entire genre has not been checked out in the past decade. Using summary statistics of features of the lowest scoring items, as well as summary stats of the scores themselves, we plan to iterate with the library to find a scoring system that recommends removing the right types of books.
Along with the 5 features we used in the initial scoring process, we extracted further features. Based on the library's feedback, we plan to modify these features and determine their corresponding weights. Then we will incorporate these features into each volume score to create a more comprehensive score. One example of such a feature is total loan duration, which is the amount of time in days for which a volume has been checked out. A higher value thus indicates a higher likelihood of being kept in the collection, as that volume has been widely used over the past 10 years. We also plan to extract further features that we have brainstormed, but we have not actually extracted already. An example of such a feature is a volume new relative to the publishing date? This determines if a volume's publishing date is recent relative to 2024 or today. We would like to add this feature because while the data we have includes publishing date, the library does not collect data of when it acquires a record to its collection. Hence, this new feature might offset the fact that older books in the collection have the opportunity to get checked out more, and we do not want to penalize newer books with not having as many checkouts.
From our work throughout the quarter, we now have a replicable process for processing our data, labeling genres, extracting features, and scoring items. Starting with the library's originally provided data, we're able to clean and reformat the datasets of the library's collection and item usage, extract relevant features from both datasets, score items based on features and their assigned weights, and finally evaluate those weights by finding summary stats about the n lowest scoring items, with n being the number of items to be moved offsite. With further iteration on features and weights, we now have the foundation of a reusable tool for determining which items to store offsite versus onsite. Thank you.